In this video, I am going to discuss about Bernoulli's equation, which is easily reducible to a linear equation. And in the previous video, we know how to solve a linear equation. So, how to reduce the Bernoulli's equation in linear equation? The standard form of Bernoulli's equation is dy dx plus pxy equals qx y to the power n. And note that y is greater than equals to 2. If y is less than 2, the equation 1, that is Bernoulli's equation, automatically reducible to a linear equation. So how to reduce this Bernoulli equation to a linear equation? First, multiply the whole equation by y to the power negative 1, because we just want on the right hand side only function of x, that is we want only q on the right hand side. So multiplying y to the power negative n, will get y to the power negative n dy dx plus p of x y to the power 1 minus n equals q of x. Now, second and important thing, we have to substitute this y to the power 1 minus n, or in the other word, we can say the coefficient of p of x. So, y to the power 1 minus n, this is equals u. And the whole equation will be reduced to a linear equation where the unknown function is u. Now, for better understanding, consider an example. Dy dx negative y equals 2x upon e to the power x y square. So here we have y whose power is 2. So this is nothing but a Bernoulli's equation, and we want to reduce it to a linear equation. And for that, first multiply by y to the power negative 2. So y to the power negative 2 dy dx, then negative y to the power negative 1 equals x upon e to the power x, and name it equation 1. Now substitute this y to the power negative 1 as u, or we'll get negative y to the power negative 2 dy dx equals du dx. So the equation 1 becomes negative du dx, because negative y to the power negative 2 dy dx is du dx, negative u, and on the right hand side we'll get nothing but 2x upon e to the power x, or du dx plus u equals negative 2x upon e to the power x. Name it equation 2. And this is nothing but a linear equation, and we know how to solve it. So the integrating factor is e to the power integration coefficient of u, that is 1 dx, or integrating factor is e to the power x. So therefore u into e to the power x, that is integrating factor, equals integration on the right hand side negative 2x upon e to the power x times the integrating factor dx plus c, which is integrating constant. So we will get negative 2 integration x dx plus c, or negative x square, because integration of x is x square upon 2 and 2 gets cancelled, we will get negative x square plus c. So therefore u is nothing but e to the power negative x times c minus x square. But our original equation was in y, so we have to substitute the value of u, that is y to the power negative 1. So from here we will get y to the power negative 1 is e to the power negative x times c minus x square, or y is 1 upon e to the power negative x times c minus x square. This is the answer.